Okay, so continuing our discussion about symmetry, there is a particular kind of a symmetry that's associated with functions, and it goes like this. We say that a function that has symmetry to the y-axis is said to be an even function. In this particular case, it means that substituting in negative x in place of x gives us the same y value out. That is to say, f of negative x is equal to f of x. A function that has symmetry to the origin will be odd if f replacing negative x gives us the same thing as the negative of the y value that we would have received. If you want to go back here, we can look at the original functions that we looked at this thing, and these two guys right here are functions. They pass the vertical line test, and for these functions right here, it turns out that we can say that in this first case, f of negative x is the y value that we get here, and f of positive x is the y value that we get here, and we get the same y value out. In other words, f of negative x is equal to f of x. It's a function that has symmetry to the y-axis. If it has symmetry to the origin, substituting in negative x into the function results in the negative of what we would get for f of x. Right? If y is equal to f of x right up here, the negative y equals the negative of f of x. That is, f of negative x equals negative of f of negative x is equal to the negative of f of x. So we have a function that has symmetry to the origin. We call it odd. What does that mean in terms of our functions, however? Well, in terms of our function, we can apply this expression directly with one single test, and that test is this. We determine if a function is even or odd by replacing x with negative x and see if the function changes according to one of these two definitions above. So let's see how this works out. Let's try it in our first case. We've got h of x equals 4x to the fifth plus 5x. So in our test, we would replace x with negative x. What happens? Well, h of negative x is the same thing as 4 times negative x to the fifth plus 5 times negative x when we take a negative number and raise it to an odd power, it's the same as the negative of the expression, so we would take the negative of 4x to the fifth, and 5 times negative x is the same thing as the negative of 5x. Now you'll notice something peculiar right here. We had positive 4x to the fifth and positive 5x. In our original function, we've got negative 4x to the fifth minus 5x when we changed h of negative x by rewriting the function. And you'll note that it looks as if I could just simply factor out negative 1 from all of the terms on the right-hand side of this equation and get 4x to the fifth plus 5x. Well, this is the original function h of x, and therefore h of negative x is equal to the negative of the original function h of x, and it fits our definition for an odd function, and so we're going to say h of x is an odd function. It would have symmetry about the origin if we were to graph it out. Well, how about g of x? Well, g of x is a function where we can substitute in negative x again and see what happens. G of negative x, when we test it, is going to be the same thing as the absolute value of 3 times negative x. But this is really the same as saying the absolute value of negative 3x. And the absolute value of a negative is exactly the same as not having the negative at all. And since this function is equivalent to the original, we say that g of negative x is equal to the original function g of x, and therefore this function is even. Now, are those our only choices? Well, no. Let's check out this last one right here. We've got f of x equals x cubed plus 3x squared. What happens when we substitute in negative x for it? Well, substituting in negative x reveals that we've got the negative of x quantity cubed plus 3 times the negative of x quantity squared. Rewriting this again results in, that should be a negative there, rewriting this again results in the negative of x cubed plus 3 times x squared. Squaring a negative x is the same thing as just positive x squared. Now, is there some way that we can rewrite this as the original function? Well, factoring out a negative like we did in the first case isn't really helpful, because that's the same thing as the negative of x cubed. Pardon me, there should be a parenthesis right here, not another f. That is the negative of positive x cubed minus 3x squared. So f of negative x does not equal the negative of f of x, so we say it's not odd. And we could certainly say that f of negative x does not equal the original function f of x, for sure, so it's not even. And so by elimination, we would have to come to the conclusion that it is neither even nor odd. And that's our third choice. The function could be odd or even, but it doesn't have to be either one. So we would say it's neither even nor odd. Okay, more to come in the next videos.